Hello there, math lovers. Welcome to another interesting math adventure on my YouTube channel. In this episode, we are going to tackle the intriguing task of calculating the product of tangents for some truly ugly angles, so to say. So let us see what we can do about this problem. So the problem wants us to find the product of tangent value of 6 degrees times tangent of 42 times tangent of 66 times tangent of 78. We don't have any formula for these ugly angles, so how can we solve this problem? So let us see if we can first simplify a little bit, simplify what the problem wants us to find. So if I take, let's say I take A to be 6 degrees, then I can say 42 is basically 36 degree plus 6. And we know actually P over 5 is nothing but 36. Then also I can say 78 will be 2 times 36 plus 6. Also 66 cannot be written directly, but instead of 66, I will assume basically I calculate 180 minus 66, which is basically 114. And that is nothing but 3 times 36, which gives me 108 plus 6. So I can say, well, let's call that product P. Then P is nothing but tangent of A, which is basically 6 degrees, and 42 was tangent of A plus pi over 5. And by the way, 78 was tangent of A plus 2 pi over 5. And 66, we know that, again, from trigonometry, we know that tangent of P minus x is basically nothing but minus tangent of x, okay? So that is basically minus 1 tangent of a plus 3 pi over 5, okay? So we have this formula right now in front of us, and yeah, how can we solve this problem for a in general? To be honest, this is very difficult if you have never faced the formula which I'm gonna reveal right now. But I just gave you this intuition that product can be written in a more neat way, in this way. But before I try to give you the formula so that you can calculate this product, let me take you on a journey. So I hope all of you, and the journey starts as the following. I hope that you all know that sine of 3a can be written as, let's say, we know there is a formula for it, and that it can be written as 3 sine of a minus 4 cosine, this is not cosine, 4 sine 3 of a, okay? And also cosine of 3a can be written as 4 cosine 3 of a minus 3 sine 3 of a, okay? So we have these formulas here, and next what I am going to do, let's first look at this sine 3. So I'm going to look at this expression on the right side because it's an algebraic expression. What I will do is I'll put sine of a equivalent to some new variable. I call it x. So what I will get is basically 3x minus 4x3. And I put this equal to sine of 3a. Okay, so a here, a is basically a constant. It's a constant value, and x is a variable, and I would like to solve this problem. Okay, so it's a cubic equation. What are the roots? X1, x2, and x3 for this equation. I know you're just wondering why I'm doing all of these things, but you will see in a minute why I'm doing all of this. So what I will do is here, because of this similarity between the left-hand side expression 3x minus 4x3 and also the formula for sine of 3a on the right side here. So what I will do is I will assume that x is basically, well, I do some change of variable. I take it x to be sine of some, I think this is called lambda. So if that is the case, if x is sine of some lambda, I know that you might think, well, what if x is greater than 1? And yeah, sine of lambda is always between -1 and 1. So, well, you can assume that actually lambda is a complex number. In that case, sine of lambda can be even greater than 1 or less than -1. So that should not, in general, it should not create a problem. I am allowed to do this change of variable. So next, basically, what I get is 3 sine of lambda minus 4 sine 3 of lambda is equal to sine of 3a. Again, a is constant. So the left-hand side, well, I purposefully designed my a cubic equation to in such a way that the left-hand side resembles the expansion for sine of 3a. So this is nothing but sine of 3 lambda, which is basically equal to sine of 3a. And this is a very well-known trigonometric equation which can easily be solved. And we know the answers for these equations are 3 lambda is equal to 3a plus 2 kp, and 3 lambda is equal to pi minus 3a plus 2 kp, and k is some integer, right? So this gives me basically lambda is equal to a over 3 plus 2 kp over 3, or lambda is equal to pi over 3 minus a plus 2 kp over 3, okay? So if lambda is these values, I'm trying to find x, right? So let us calculate x. X was sine of lambda, so then I get x equals sine of either, I take the first one for the moment, so sine of a over 3 plus 2 kp over 3. And if I vary k for different values, then I can get different values for x. But what about the second one? Well, I can prove to you it doesn't matter whether you put lambda first one or the second one. And the reason for that is the following, because if I take, let's take the second one. If I take x to be sine of pi over 3 minus a plus 2 kp over 3, I can prove to you that this will generate the same answers as the first one. Why? Because this can be written as sine of pi minus the angle undersigned, right? So it would be pi minus pi over 3. I'm using basically these identities. Sine of pi over x is equal to sine of x. So basically I do write pi minus this whole angle, and then it becomes a minus 2 kp over 3. But this can be written as sine of basically, this is basically 2 pi over 3. Then I can write a plus, I factorize 2 pi over 3 times 1 minus k. But you can take 1 minus k as some new k prime because that's also an integer. So basically you have sine of a plus 2k prime p over 3. But is there any difference between this guy and this guy? Sorry, I think here we made a mistake here, because here this should not be actually 8 over 3, this should be a. Sorry for my mistake, but it basically nothing changes, right? So that is a, and probably you have all this time been wondering why I made that mistake, so I corrected it. So yeah, now let us find the different values for x. So if I put k equals 0, then I get basically x1 is equal to sine of a. Then if I put k equals 1, then I get x2 is equal to sine of a plus 2 pi over 3. And if I put k equals 2, then I get x3 is equal to sine of a plus 4 pi over 3. But this can be written as minus sine of, you just basically pull out 1 pi from this and use some trigonometric identities, and then you get minus sine of a plus pi over 3. Interesting, right? Now, these are basically the roots to this equation up here, which I designed myself. Now let us reorder that equation for a second. So basically we have 3x minus 4x3 was equal to sine of 3a, and a was constant, and these are the roots of this equation. Very interesting. It's a very special algebraic equation where the coefficients are purposefully designed to resemble the coefficients of the expansion of sine of 3a. It's very interesting. So here, what I do, I first reorder this. So then I get 4x3 minus 3x plus sine of 3a. This is equal to 0. Let us divide both sides of the equation by 4. Then I will get here x3 minus 3 over 4 x plus 1 over 4 sine of 3a is equal to 0. But we know that this equation has these roots up here, x1, x2, x3. And we know that the equation can be written as x minus x1 times x minus x2 times x minus x3 equals 0. And we know that the constant, when you expand this algebraic equation, the constant value, it means the coefficients of the power 0 of x will be minus 1 to the power of 3, x1, x2, x3. And this is nothing but the constant value in this equation up here, which is basically 1 over 4 sine of 3a. Okay? And I have x1, x2, x3, interestingly, based on a. All I need to do is to replace them. So x1 doesn't have any negative value, this as well, but this one has a negative value and a negative sign. And basically, that negative sign will be cancelled with this negative sign here. Then I will get sine of a times sine of pi over 3 times sine of, I'm sorry, I have to put a plus pi over 3 times sine of a plus 2 pi over 3. This is nothing but 1 over 4 sine of 3a. So let's just bring that 4 here. In other words, I can write sine of 3a in this way. So it goes without saying that actually you can do a similar thing for cosine of 3a. And if I go back to the expansion of cosine of 3a, then I can like before, form a cubic equation such as 4x3 minus 3x equals cosine of, let's say, 3a, and you can take x to be cosine of some lambda and solve the equation. And interestingly, you will find out actually you have this formula minus 4 cosine of a times cosine of a plus pi over 3, okay, times cosine of a plus 2 pi over 3. This is equal to cosine of 3a. You can also get this formula, but why did I get all these formulas? Because as you can see, the terms are very similar. They follow the same pattern. It means if I basically divide both sides of these equations, then on the right side, I get tangent of 3a is equal to 4 and minus 4. They will be cancelled. Minus will be left. So then I have minus tangent of a times tangent of a plus pi over 3 times tangent of a plus 2 pi over 3. This is a very interesting formula. Although this is not going to help me solve what I was trying to find in the beginning of the problem here. Basically, there we had tangent of a times tangent of a plus pi over 5 times a plus 2 pi over 5 times a plus 3 pi over 5. However, if I basically repeat what I did for sine of 5a and cosine of 5a, I can actually find a formula for tangent of pi a based on those values up there. So guys, this is going to be a tedious job. I am not going to do it, but just for you to know that you can actually calculate sine of 5a as the following. Sine of basically 3a plus 2a, and then you just expand it. This is sine of 3a cosine of 2a. You have formula for these guys, plus sine of 2a times cosine of 3a. You can also do the same for cosine of 5a. And the formula you get for these two guys, I will let you calculate these two yourself, but because there is no point for me to prove that. So this is basically 16 sine 5 of a minus 20 sine 3 of a plus 5 sine of a, okay? And interestingly, cosine of 5a can be written as also 16 cosine 5 of a minus 20 cosine 5 of a plus 5 cosine of a, okay? So all I need to do is to form an equation, algebraic equation of order 5, such as 16x5 minus 20x3 plus 5x, and put that equal to sine of 5a. And then if I take x to be, for example, sine of 5 gamma, then the left hand side of the equation is basically the expansion of sine of 5 gamma, lambda. Then I get basically sine of 5 lambda is equal to sine of 5a, and I can solve this equation again and find out that actually lambda is a plus 2k pi over 5, and another lambda will be a no, I think this is pi over 5 minus a plus 2k p over 5, okay? And interestingly, if I I think here I made a mistake. I should have assumed that x is equal to sine of lambda, because then the left hand side will be sine of 5 lambda. And if I just basically put lambda into x equals sine of lambda, that basically I get these values, sine of a plus 2kp over 5. You can also try for the second one, and similar to basically what we proved for order 3, it will generate the same responses. Again, this is an exercise for you. I don't do it, but trust me, this is already enough to generate all the responses for x, because this is a equation of order 5 and we know we should have 5 answers. So one x will be basically k0, this is sine of a, and then another x will be sine of a plus 2 pi over 5. Then I have basically x3 is equal to sine of a plus 4 pi over 5. Then I have x4 is equal to sine of a plus 6 pi over 5. Actually, this can be simplified. This can be written as minus sine of a plus pi over 5. I just simplify it here. And then x5 can be written as basically sine of a plus 8 pi over 5, which can again be simplified as minus sine of a plus 3 pi over 5. And again, similar to what we had for order 3, the constant value in that equation of order 5 will be something like minus 1 to the power of 5, x1, x2, x3, x4, x5, which in this case will be minus 1 over, because you have to bring sine 5a to the left side, and then you have 1 minus there, over 16 sine of 5a. But we also have some values for x1, x2, x3, x4, 5. And by the way, these minus will be cancelled here. So then you get sine of a times sine of, you have here 1 minus, and also here, so you have 1 minus, here 1 minus. These minuses will also cancel out each other. Then you get sine of a plus pi over 5, sine of a plus 2 pi over 5, and sine of a plus 3 pi over 5 times sine of a plus 4 pi over 5. This is nothing but 1 over 16 times sine of 5a. So I already found an expression for this guy. And interestingly, you can also find a similar expression for basically cosine of 5a. So what you get is basically cosine of a times cosine of a plus pi over 5 times cosine of, I don't prove it because it's very similar. The equations are also completely the same, okay? And it can be proved that they are just, yeah, they have the same structure. So this is cosine of a plus 3 pi over 5 times cosine of a plus 4 pi over 5. This will be equal to 1 over 16 cosine of 5a. And similar to what we had for tangent of 3a, we just basically divide both sides of these equations. And then I get tangent of 5a is equal to tangent of a all the way to tangent of a plus 4 pi over 5. And by the way, we have also, yeah, the sixteenths will cancel each other. So we don't have that. So we have this beautiful formula, okay? And now let us take a to be 6 degrees. So then we have here tangent of 30 will be equal to tangent of 16. And by the way, here on the second part, we have a plus, yeah, pi over 5, which is 36. So then I have tangent of 42, and then I have tangent of 2 times 36 plus 6, which is basically 78, and then tangent of 3 times 36 plus 6, which is basically 114, and then tangent of 4 times 36 is 144 plus 6 is 150 degrees. But just pay attention that tangent of 150 is basically minus tangent of 30, okay? And we have here tangent of 30, so these guys cancel each other. I have only one minus, and by the way, this is nothing but minus tangent of 66, and these two minus also cancel out each other. So what I get is basically this tangent of 6 degree times tangent of 42 degree times tangent of 66 times tangent of 78 is basically equal to 1. This was what we wanted to calculate. I hope that you enjoyed this very complex and sophisticated solution. I give you rights if you basically in the beginning could not straightforwardly find the solution to this problem. Obviously, you should have known about that formula, but that was the beauty of it. So there's always something which surprises you in mathematics. I hope that you really enjoyed this solution. If so, please do not forget to like my video and join my community by subscribing to my channel. I'll be posting more interesting problems. I really personally love these problems, and I like to share my solutions and explanations with you guys. Stay tuned and see you next time.